Okay, so this video is, I want to say, still part of the introduction. I don't want you to really take notes on this video, or if you want, you can. It's not really something that I want you to, but it's not really learning. I just want you to, I just want to show you how we can use reverse engineering for, in this case, malware analysis. And I just want to show you how powerful reverse engineering can be. And I myself, I am not the best at reverse engineering. I'm not at all. But I'm decent. So for this, I'm using IDA freeware, as I said in the tools we'll need section. And all I did was I just opened our keylogger.exe file that we made in Visual Studio. If you don't know what I'm talking about, it's in the keylogger playlist. I just made a keylogger program that logs keystrokes. Pretty simple. And I really suggest you watch that so you can understand what I'm doing here. But yeah. So when you load IDA, and actually let me put this back. So okay, this should go right. I have no idea where this was. So I'm assuming it was here. So yeah, when you load IDA, you'll be on a screen like this. So let me actually close this here. Okay. I'm just gonna go ahead and reopen this file again. Don't save database, and as you can see, keylogger1. Open this, and I opened the incorrect file. So you wanna, sorry, you wanna just click keylogger, and you wanna click this, click OK, and click no here, because I wanna show you how I would do this if I only had the binary executable, so just the exe file. If you have the PDB file, then you'll actually be able to get function names and way more accurate data, but that's very unlikely if you are doing a penetration test, if you're doing like a black box penetration test, but that's beyond the scope of this video. So when you load into IDA, you'll be presented with a graph. So, and this graph is just this isn't really an IDA tutorial. Again, I don't want you to take notes, but this is just like this is the code flow. But I don't want to show you that, but I want to show you something else. So these are functions that are actually defined in IDA, or IDA finds that are defined in our code, and most of them are useless. But if I click around, you'll actually be able to see that we see our actually before I do that. So in IDA, you can go to imports, and you can actually see what functions and APIs they are importing. So if you were doing an analysis on this keylogger file and you saw get current process ID, get current thread ID, although this isn't super uncommon in almost every program, it gives you some ideas that like, okay, the Windows APIs are being used. We see just iOS stream here. We see thread, so threads are being used. Get foreground window, that's something interesting. Get window text A. Get thread process ID, get async key state. This would most of the time tell you it's a keylogger because not many programs actually, from what I know, don't use get async key state. So this program is using these functions, and you're able to get an idea of what is being imported into this program. There's some more stuff like hex view, whatever, but we're not gonna get into that. So if you do F5 on IDA, IDA Pro will actually, IDA will actually try its best to decompile this code and give you an idea of what it looks like. So we'll try to predict the code pretty much. And looking at this code, we can immediately tell this is our keylogger. If get async key state 13 and 13 in hexadecimal 13 represents the return key, so you can immediately tell this is a keylogger. Like here, it's doing a for loop between 48 and 57. So you can assume this is logging the keystrokes, and there's a sleep here, so we can rename this function, and this is why IDEA is super powerful. We can actually edit this function, and we can rename this keylogger. And obviously, you would not be analyzing a program this quickly. It took me 30 minutes of analyzing this, and I already knew my source code in order to come up with what I'm about to show you. So keylogger. Here, but so this is a keylogger, and sleep. We can just call this, and you're able to rename variables too. We can call this delay, because the C++ sleep function, if you didn't know what this was, you would do research and you would find out that that's meant for obviously sleeping in between the while loop here in this case. So you're able to immediately tell like get async key state, and if you didn't know what this function meant, you would obviously do your research. You would search up what is get async key state, what is its usage, and then you would know this is a keylogger. And if you go in the main function, and again I already did all of this, so I know where everything is. And again, it took me 30 minutes to do this on a machine code that I already knew the source code of. But that's besides the point. So we can go down here, and I believe it is this function, right? And again, IDEA does a great job of trying to guess what the code is. So this is a while loop, and get window third process ID. It's getting the window text A of that foreground window, and it's storing it into string. So we can actually just like again, you can rename stuff. So maybe we can rename this to active window, and it is outing that active window. So we see that this file is getting that getting the thread process ID of the foreground window. It is getting the window bar title of that foreground window, and it is printing out. So we can already get a great visual. We can already get a great visualization of what this program looks like. So we know there's a keylogger, and those keys are being outed. So A, B, C, and we also know that the foreground window and the bar title of that foreground window is also being outed. So notepad, so we can, and it's PID, process identifier, and let's just say in this case it's 1, 2, 3, 4. So we can get a visualization of what this program will look like without ever running this, because it is malware. So without ever running it, we can get a visualization of what this program will be printing. So this would be the virtual keys that is being logged. This would be the foreground window. So yeah, and we can rename these functions. So sub 1400250 and I have no idea how to get there quickly, so I'm just gonna scroll until I find it. 2050 205, and actually we can just rename it right here. I have no idea why I'm doing it like this. You could just rename it right here. So this is, we can call this like we could call this, but we can just call this what we call this in our actual code. So why am I not able to rename global item? Yeah, so we can call this, I guess, process info. And obviously if you're analyzing this without ever what this code looks like, you would name it something else. I'm just giving an example. So from just that, we're able to see that our main function is beginning a thread with our with a keylogger function and a process info function from what we think they are. Obviously these have their own names, so we just renamed them right now. Now if you go up, we're able to see this stuff. It is doing all this, and this might look intimidating, but I'm going to break it down super quickly. So this is saying if argc less than 2, so if there's less than 2 arguments, So keylogger.exe and no argument, just keylogger.exe is going to go to label 11. And if you highlight label 11, you're able to see where label 11 is mentioned. And we can see here label 11 is mentioned again. It's saying if envp equals const 6 whatever. So this isn't important. But if you highlight v7, you see that v7 is equal to v6, and v6 is actually our first argument. And again, this might seem confusing, but you'll get it. So this is just saying if the contents of v7, which is v6, which v6 is our first command line argument. So if our first command line argument, the contents, and memory compare just means comparing. And the reason it's saying not memory compare is because that returns 0. Memory compare returns 0 if it's true. I believe, I'm not sure. But this is just comparing. And actually, I could look this up, mem compare. And it compares the first bytes of the block memory pointed to. So it just is comparing the contents of v7 to the string of dash dash help. And as you can see here, the contents of both memory blocks are equal. So if not, that just means if this is 0. So if the first argument is equal to dash dash help, pretty much we're going also to label 11. So we can see if there's less than 2 arguments, we go to label 11. But if our first argument is equal to dash dash help, we also go to label 11. And label 11 initializes v10, and it says v10 is equal to 1. And here we see another one. It's saying if, again, but here we don't know what v9 is. v9 is equal to v8 right here, and v8 is still our first argument. So it's again saying if our first argument, again, but this time, if the contents of our first argument is equal to the string of dash h, then v10 is equal to 1. And v10 is equal to 1, if you remember, in label 11. So if less than 2 arguments, dash dash help or dash h, v10 is equal to 1. Now what if v10 is equal to 1? If v10, and let me double click this, if v10, so if v10 means if v10 is equal to 1, if v10 is going to print all of this, and std chart, you can just tell this is a print statement, std out. So you see how we were able to actually break this code down in a very efficient manner with IDA. So let's move on past this. And we go down here and we run into this. So v20 is equal to, so this is our first argument. v20 is equal to, our first argument here is sorting to v20 right here. And that's just there for now. Let's just ignore that for now. And we see here an integer is assigned. v22 is equal to 1500. We don't know what that's for right now. We do, but I mean in as if like we don't know what the file is. You know what I mean. So here we're saying if argc less than 3. This might seem confusing, but as we saw up here, if argc is less than 2, it prints this, which is like a guide from what we can tell here. Pretty much like an error. So if argc less than 3, we can just safely assume this means if there's 2 arguments. So if argc is less than 3, here let's just assume 2 arguments, we're going to label 38. And label 38 initializes v25 and it sets it to 0. So what if not v25? So here we're saying if not to v25. So that means if v25 is 0, we are just running keylogger with v20. And if you remember our keylogger function, it actually takes in a parameter right here, dword delay. And we actually did rename that into delay. That's not what it was called before, but yeah. So we could just go ahead and call this delay. And rename my var. We can just call this delay here to help us better see. So if there's two arguments, then we are running keylogger with that second argument. And you're probably wondering how this makes sense. If we actually, can I go back? Yeah. So if I highlight v20, I'm confusing myself. But you can see it's just running vlogger. If there's two arguments, it's running keylogger with its argument, which was the sleep argument, if you remember, in our keylogger function right here, sleep delay delay. So we broke that down now also. So now let's just say there isn't two arguments. Let's move past this. So now but by now we're able to actually tell the keylogger function is sorry, the keylogger function takes it logs keys and it takes an argument for how much to sleep for in between keys. It's pretty obvious. There's a while loop here. There's another while loop here. We can just assume it's doing that to delay how fast it logs the keys. So yeah, and we're able to get that much information by just decompiling with IDA. So we move past all of that. Then we run into this. If v19 is equal to, and v19, I believe it's a pointer to v23, and v23 is our second argument. So if the contents of our second argument is equal to dash I, then v25 is set to 1. But what if v25 is set to 1? And we see if not v25, so that's not correct. And if v25 is equal to 1, this means it's not equal to 1, so we can move past this and we get here. So if v25 is equal to 1, this is what happens. Although there's no else statement, we can tell because that's how code works. So we go here and we see v28 is equal to delay. But what is v28? And v28 here, I believe it represents our it's representing the delay argument, but we don't know what v28 is right now. So that's not super important right now, but we can tell that it is running our so if there's the dash I argument, it is running it with this process info function down here. Oh, I'm sorry, this is the keylogger. I thought this was the process info. I'm sorry. So and again, so if not v25, so if there's if there's two arguments and our second argument is equal to, I lost it. Yeah, if our second argument is equal to dash I, as you can see here. Oh, it actually highlights it for you. Oh no, it doesn't. But yeah, so if our second argument is equal to dash I, and this checks if it's not if it's dash I, it says v25 to 1, but this checks if it's not v25. So we move past this because that's not the case. So if it is v25, there's no else statement, but again, we can tell I'm back to where I was started. But it's running the keylogger function with its delay argument in a thread, and you can tell because it's saying begin thread X. And if I click into this, you can get more information about this right here. But begin thread X in C++ essentially just means decompiled. This obviously means it's starting a thread. So if our second argument is dash I, we can tell it's starting the process info and the keylogger function in a thread. So we get more information about our second argument. Cool. But what if we don't have a second argument? If we don't have a second argument, then it just runs keylogger with delay. And that was the same with if we only had two arguments. So if we don't, one argument. So if we don't have a second argument, if not v25, then we just run it with the first argument that we provided. So you see just how much information we're able to get with this. And this video is getting kind of long, but I'll keep going. And here, we're able to see v28 is equal to delay. So we can tell keylogger is running with the delay function. But here, process info is saying v29 is equal to v22. But what is v22? And if you highlight it, you're able to see every instance. You can also double click on it. And you can see v22 is actually our third argument. So our second argument is -i. Our third argument, this looks like a char argument again. And if you scroll up, if you remember, v22 is equal to 15,000. So if we look at our process info function again, would you look at that? So it's taking a sleep argument. So we can change this to process info delay. And actually, we can change. I believe we should change it. Let's just change it here. So we can tell this is the argument, the sleep argument. So we can change this to process info delay. So it's running process info delay with the third argument right here, as you can tell. But process info delay is set to 15,000. So what's up with that? If we check here, it's saying if argc is greater than or equal to 4. So this is just basically saying if there's 3 arguments, if there's 4 arguments, keylogger.exe, the speed argument, the -i, and in this case the the process info parameter, I'm assuming, because we know -i represents the process info. Obviously, because of this. If this wasn't here, we wouldn't know, but just for the sake of this video, we know what that represents. So if there's a third argument, then process info delay is actually equal to that argument. So it's stored into process info delay, and it is running the process info delay. It is running process info function with that sleep argument, which is process info delay right here. And this is just checking if there is 3 arguments. There doesn't have to be. So, and if there isn't, you can see process info delay here is set to 1500. So if there is no third argument, it's just going to run it with a 1500 second. Why am I saying second? 15, and why am I saying 1500? 15,000 millisecond delay. I apologize. 15,000 millisecond delay. And it is running it with those threads. And it's running them in threads. So you can see just how powerful reverse engineering can be, how much information you're able to get with reverse engineering if you just sit here for a few hours and look at a program. And yeah,